So here we go, a little bit more information on oxidation numbers. Again, this would be the charge that the atom assumes. This is super helpful, especially if you're looking at a redox reaction where one atom is oxidized and another one is reduced. And so if we take a look here, as I'm looking at this first one, sodium sulfate, I know that this 2, if I uncross it, had to have come from sulfate. So I know that sodium had to be a 1+. And sodium's almost always a 1+ because it's a group 1 metal. So what's the charge of the elements in sulfate? Well, I know that the overall charge here was a 2-. And from just the oxygens themselves, it would be 8-. So the only thing that sulfur could be in this case is a +6 to get that 8- and an overall -2 charge, since 6 minus 8 is going to be -2. Let's take a look at this next one, iron 3 nitrate. And of course, this 3 came from iron. And so our iron here would be a 3+ charge, which means that our nitrate overall was a -1 charge. So if we're taking a look at that, we've got a -1 charge. So and that should be a -1. It sort of looks like a plus, but it's a -1. So that means that the oxygens here, 3 of them, each oxygen -2. So we've got -6 from oxygen. So that must mean that nitrogen is a +5. Now this would be a good time to pause this video and take a look at the rest of the examples here now that you've kind of warmed up with those and see what you can do. All right, and now that you're back taking a look at these, strontium is a group 2 metal, so it's going to be a 2+. Carbonate, of course, is a 2-. It's one of our polyatomic ions. And so 3 oxygens, totally -6 with an overall -2 charge. That means carbon has to be +4. All right. The next one, hopefully you've already done this one, so you're just sort of checking to see if you're doing them correctly and getting some extra practice. Sodium sulfite, right? And so this 2 obviously came from sulfite, so that's a -2 charge. Sodium's got to be a +1 because it's a group 1 metal. So if I take a look at SO3, with an overall -2 charge, so that's going to be -6 from the oxygen, so sulfur's got to be a +4. Was the only thing that it could be to allow for a -2 overall charge. Calcium chloride is our next one, and obviously calcium is a group 2 metal, and so this 2 came from there. So this is going to be Ca2+. Which means that chlorite was a -1 overall. That's why you need 2 of them to equal 0. Remember, compounds always have a neutral charge, so you had to have 2 of those. An oxygen, of course, is a -2. So that means that chlorine must be, which is very unusual, we're not used to seeing chlorine like that in this situation, would have a charge of a +1. And that's why it's important to be able to look at these and determine the oxidation numbers. So I hope this helps you. Make sure that if you have any other questions about these oxidation numbers, you be sure to talk to me. And now let's move on to a couple of stoichiometry examples, because I believe that's the next thing that I have in our list of things that we want to go over. All right, these were the 2 practices that we did not get to last evening. So I did want to make sure that we went over those today. So let's go ahead and take a look at these two stoichiometry examples. All right. And so our first one starts with, if we have 16 grams of copper reacts with excess silver nitrate, how much silver is formed? And so always starting with that given. 16 grams of copper is what we're given here. That's what we want to write down to start with. We're also going to need a balanced equation, and because that's the other most important thing with these stoichiometric problems. And so there is our balanced equation. And so a lot of times I like to look at the equation now and I go like, okay, so I'm trying to get copper. I know I've got excess silver nitrate, plenty of that, and I'm trying to find out silver. So right away I can look, oh, okay, so this is a 1-to-2 ratio. But of course my ratio is in moles. So the first thing I need to do then is convert my grams of copper to moles. And of course, how do we do that? With our molar mass. And so on my periodic table, that's what I had for the molar mass of copper. And obviously you can see my grams of copper are going to cancel out. Now I've got moles of copper. I can stop right here and figure out how many moles of copper we're talking about if I wanted to. And so we'll be talking about 0.252 moles of copper. And I know that it's 1 mole of copper to 2 moles of silver. And so I could also then go ahead and look at my ratio from my balanced equation. Exactly what we said, 2 moles of silver to 1 mole of copper. And now you can see my moles of copper have canceled out. I've got moles of silver. And so now we're going to look at converting to grams of silver. And how do we do that? That's our molar mass from the periodic table. So there's our molar mass of silver. Notice that now our moles of silver have canceled out or diagonally dropped. And I go straight across the top and multiply 16 times 2 times 107.87 divided by 63.546, the molar mass of copper. And I came up with that long answer. Of course, I need to round that to significant figures. There were 3 given in my measurement in my problem, and so I'm going to round that to 3. So 54.3 grams of silver would be formed from 16 grams of copper. That's not a bad deal. Now, if we take a look at this copper and we look at the oxidation numbers, because you had asked about making sure that we had done another oxidation example, take a moment and see if you can figure out the oxidation numbers of each item, each species in this equation. You can keep the nitrate together. You don't have to do nitrogen and oxygen separate. Okay, so obviously the copper is a 0 there. It's a 0 there because it's by itself, and the silver is a +1. Nitrate is a -1. So my silver now is by itself, so it's going to go to 0. So it went from +1 to 0. So I would say that is a reduction in charge. It has been reduced. And I'm just going to put reduced. And now let me look at my copper. My copper, if I uncross this, the oxidation number of my copper is a 2+. And nitrate, of course, is still a 1-. And so my copper, if I take a look at it from here to here, has been oxidized. Remember, oxidation is loss. So it has lost some electrons, obviously 2. That's why it's a +2. And my silver has been reduced. It has gained an electron. It went from being a +1 to being a 0 charge. So I hope that helps you as you're taking a look at these and these oxidation reduction reactions. We're going to kind of see everywhere. All right, moving on to our next stoichiometry example. All right, here we go. So what's your first step? Yep, write that balanced equation. Now here's my equation. Obviously, it's not balanced. Oh, my aluminum probably should have been a solid here. I don't think it's going to be aluminum as a gas. So how do I balance it? Well, when I started, I had put a 2 here. And then I found out that that 2 didn't work. And so I then had to change it to a 4 and a 2 there. So there's our balanced equation. All right, so see if I would suggest you stop the video and see if you can do this one on your own now that you've got a balanced equation. Then start playing again and take a look at it. So of course we're going to start with 6.50 grams of aluminum. Our molar mass of aluminum, that's going to allow us to go from